Whoa, we doing this thing for show. We got problem 2452, words with two edits of dictionary. That shit don't rhyme, don't care. I'm doing Leetcode in my underwear. Okay, words within two edits of dictionary. Does anyone else think that sounds kind of weird? Words within two edits of dictionary. It's not a sentence I would use regularly in everyday communication. Okay, so you're giving us two string arrays. You're given two string arrays, queries and dictionary. All words in each array comprise of lowercase English letters and have the same length. All right, so that's kind of cool. Whatever this is, it doesn't seem like there's not going to be edge cases that we have to really think about because everything's the same length. It's always nice when something problems like that. In one edit, you can take a word from queries and change any letter in it to any other letter. All right, this sounds like dynamic programming to me, but I haven't read the whole problem yet. But find all words from queries that after a maximum of two edits equals some word from dictionary. Return a list of all words from queries that match with some word from dictionary after a maximum of two edits. Okay, so you can only edit a word twice. So you can change two letters of a word. Now, since all the words have the same length, that really just means taking a letter and changing it. Okay, so if I look at a word from query and a word from dictionary, if I look at each slot, and the letter's only difference twice, right? So there's only two slots in the word where the letter's different, then that's a valid word that we can return because it would take a maximum of two edits. Return the words in the same order that they appear in queries, right? So, for example, like word, right, is a query, and wood is in the dictionary. All right, so I only need to change it in this one slot, so that's a valid word. Note and joke is also an example. Why? Because I can change, right? It's only different in two slots, right? It's different in the NJ slot, it's the same. Different in the TK slot, and it's the same. So there's only two, so two changes becomes that final word. All right, and we want to return each word. So if we look at a query word, we have to find if there's a corresponding word in dictionaries with the length less than two difference. Okay, so all right, so there's only 100 queries in 100. So there's at most 10 squared work for each. So, and this is also 10 squared. Okay, so this is at most we could just brute force this and look at each query word and compare it to each word of the dictionary, right? And see if there's a candidate. Because, right, in order to compare each query word to each dictionary word, right? Well, there's n words. Let's just do that here. So let's just establish runtime for this because I'm going to justify that we're going to do a brute force solution. So n equals length of queries. M equals length of dictionary. And element O equals length of query 0. Because they all have the same length. So NMO. So if we want to do a brute force solution where we just look at for each query, we compare it to each dictionary word, right? That's going to take NM time, right? Because each query has to get compared to each dictionary word. So that's N times M operations. And then to compare each word to each other, we have to look at each letter. And that's going to take O operations. So we can have a runtime of big O of O times N times M. O was probably a bad decision here, but that's fine. And this is 100 for each of these, and these are 100. So that's 10 squared times 10 squared times 10 squared, which is 10 to the 6th. This is a bad way of doing this. What does it mean? But yeah, 10 to the 6th, right? 10 to the 6th, what, 100,000? I'm not worried about 100,000 operations. That's not a big deal. We can do brute force 100,000 operations pretty quickly. Okay. So that's what we'll do. So we'll look at each query and queries. Right? And we'll look for each word in the dictionary. And we're just going to try to find a word in the dictionary that is less than 2 off from the query in each slot. So what we do is we say, well, if the sum of A not equal B, we'll call it Q not equal W, for QW in zip query word. So we'll look at each letter, and since they're the same link, we can just zip them because they have the same link. So look at each slot. That's what this QW means. If it's less than 2, right? So this is basically saying if there's less than 2 letters that are different in the query in the word, then this is a candidate for the solution, right? This is a potential solution. So we'll have this res be our return, and we'll say, well, we have a solution, so res append this query word, because this query word has a match in the dictionary, right? There's a match because there's less than 2 letters that are different between this query and word. And then we don't need to keep checking, so we'll break. And at the end, we'll just return res. And this will come in order because we're processing the words in order. What? Word, note, joke. Less than or equal to 2. Sorry. Right, because there could be 2 different, okay? So what's the runtime of this? Well, we need to create this return array, and that at worst could be if every single word, right, in our query is a solution, then we're going to need to create a list of that size, right? There's a list of the size of the words that we return, so it's possible that every single word could be a valid max 2 difference in dictionary. So that means that every single query word could get added to this return array, so we could have as much n space, because that's the length of queries, right? And then for runtime, well, we have that here, right? Because we have to look at each query, right? So this is O of n. Then we have to look at each word. That's O of m. And then we have to check the length by looking at each letter of the word, and that's O of O. So this total thing is O and M runtime. So this is O of NMO runtime. And that's it. So let's run this, and then let's call it a day. Boom, boom, boom. Gang, gang, gang. Back in the stew.